Hello and welcome. This is Dr. Himayatullah Khan and I am going to explain correlation analysis of a quantitative variable. So let me start with my data file, that is implies data file, and here I have a number of quantitative variables like salary, salary beginning, job time, previous experience, and so on. Uh, Correlation analysis can be done between two quantitative variables rather than two qualitative variables. Between two qualitative variables, in one of my videos, I did chi-square analysis. But when we find the relationship between two quantitative variables, we are not going to analyze chi-square test, but we are going to compute the correlation between the two quantitative variables. So how can you do that? Let me first tell its theory of test of hypothesis, and here you can see that the topic is analysis of quantitative variables. Let us suppose I have two variables. One is my x variable and is y variable, and both of them are quantitative. And I want to study correlation between x and y. So the first step in test of hypothesis here would be null hypothesis, and the null hypothesis is that there is no correlation between x and y, or the correlation coefficient between x and y is equal to 0. This is my null hypothesis, and we would test this hypothesis uh, under alternative hypothesis, and the alternative hypothesis is that the correlation between x and y variables is not equal to 0, and here in parentheses you see that r is not equal to 0. The level of significance alpha is equal to 5%, and test statistic here is correlation, and then there is computation. I will just compute the correlation coefficient, and the decision rule is here. And if the p-value, the observed p-value of the correlation coefficient between x and y is less than 0.05, that is 5%, then we will reject null hypothesis. And when we reject null hypothesis, our conclusion would be that there is a correlation between x and y. If our p-value is greater than 5%, in that case we will fail to reject null hypothesis, and then our conclusion would be that there is no correlation between x and y, and we will fail to reject null hypothesis. So let us find out the correlation coefficient between x and y. Let us suppose my x variable is salary and my y variable is salary beginning. So this is the beginning salary and this is the final salary, and I want to find out correlation between these two variables. And the number of observation in this file is 474. So there is no missing value, so I can compute correlation between x and y variable. So how can I do that? Let me go to analyze, and under analyze, this time I will go to correlate, because I want to find out correlation coefficient between x and y variables. So here I will click on bivariate. Bivariate means relationship between two variables, that is, and you see R12, one is for one variable and 2 is for another variable. So let me press bivariate, and I will get this small window. Since I am going to assume that my current salary is my x variable and beginning salary is my y variable, and I want to compute the correlation between these two variables. So let me leave it. Just continue. Okay, and when I I get the correlation analysis here, and this is the table which gives us correlation analysis between two quantitative variables, that is current salary and that is the beginning salary. The correlation coefficient between current salary and current salary is 1, because current salary and current salary, if you find out correlation between two variables which are exactly the same, so current salary and current salary are the same, so the correlation coefficient between the two would be 1, and that is perfect positive correlation. But in this cell you see that under beginning salary and in front of current salary, it means that this is the correlation coefficient between current salary and the beginning salary. and this correlation coefficient is equal to 0.88, and under its correlation coefficient value, here is its p value, that is two-tailed significance value, which is the p value. So it means that the correlation between current salary and beginning salary is 0.880. Same information is also available in this row, and here there is beginning salary and there is current salary. So again, the correlation coefficient between beginning salary and the current salary is 0.880. But here in this cell, you see there is 1, and 1 means that the correlation coefficient between beginning salary and beginning salary is 1. So diagonally, these values are equal to 1, because this one is the correlation coefficient between beginning salary and beginning salary, and this correlation coefficient of 1 is the correlation coefficient between current salary and current salary. So either you can read this value or you can read this value. There is no difference between the two. But let me go to my test of hypothesis and check on the basis of this p value whether we will reject null hypothesis or we will fail to reject null hypothesis. So here, my null hypothesis is that R is 0, or there is no correlation between X and Y. Let us suppose X is my current salary and Y is my beginning salary. And then the alternative hypothesis is that there is correlation coefficient between X and Y, and that is R is not equal to 0. Level of significance, that is alpha, is equal to 0.05 or 5%. Test statistics is correlation analysis. Computation, the computation has already been done by SPSS, and you saw earlier in the table. And this is the decision rule, and the decision rule is that if p value is less than the 5%, we will reject null hypothesis, and if our p value is greater than 5%, then we will fail to reject null hypothesis. Since in this table you saw that our p value is less than 5%. This is 0.000, which is less than 5%. So we will reject this null hypothesis. When we reject null hypothesis, then we will conclude that there is correlation between X and Y, and that correlation is equal to 0.880. That is a very high correlation. That is 0.88 is a high correlation. So the correlation coefficient between X and Y is 0.880, and that is significant. Thank you very much.